If you look at almost any diet plan or like a health blog or even a magazine cover from the last 30 years, there is this underlying assumption that we basically treat as absolute gospel.
Oh, yeah, completely.
Right. It's the idea that white meat, and specifically poultry, is this ultimate, like, safe protein.
Yeah.
And red meat, especially beef, is just a dietary villain. I mean, we picture chicken as this clean, metabolic hero, and beef as this heavy, heart-clogging, blood sugar spiking disaster.
It's deeply ingrained in our culture.
I
I mean, we tend to moralize our food, right?
Yes, exactly.
Categorizing it into these strictly good and bad lists. And for anyone who's worried about their metabolic health, beef has been firmly placed on that bad list,
Right.
often with the assumption that avoiding it is like step one to taking control of your health.
So true. Well, welcome to the Deep Dive. Today, we are taking a close look at a brand new summary from Science Daily.
Yeah, this is a good one.
It really is. It's covering a study published in the journal Current Developments in Nutrition from May 2026. And our goal today is for you, the listener, to walk away with a clear understanding of what happens when we actually put that long-held dietary assumption to the test.
Right, the poultry assumption.
Exactly, because this new study, it turns the whole beef versus poultry narrative completely upside down. Okay, let's unpack this.
What's fascinating here is that we are not talking about a flimsy observational study. We have all seen those studies where researchers just ask people to fill out a questionnaire.
Oh, right, the food frequency ones.
Exactly. What do you remember eating over the last 12 months? And then they try to correlate those really fuzzy memories to why someone got sick.
Which is impossible, right? Like, I don't even remember what I had for breakfast on Tuesday.
Nobody does. But this, instead, is a rigorous clinical trial led by researchers at the Indiana University School of Public Health.
Okay.
And they set out to specifically measure how beef impacts people who are already at a high risk for metabolic issues.
And this matters to you directly. I mean, whether you are actively tracking your macros, or maybe you or a family member are managing prediabetes, or, I don't know, you are just insanely curious about how scientific consensus evolves and updates its beliefs, this deep dive is going to give you the essential takeaways.
Absolutely.
But to really appreciate what the researchers found, we have to look at the staggering scale of the problem. Like, why is the medical community so intensely focused on blood sugar and meat consumption in the first place?
Well, the focus is driven by the sheer overwhelming numbers. The text highlights a really startling statistic.
Yeah, this blew my mind.
Right. Right now, more than 135 million adults in the United States either currently have type 2 diabetes or they face an elevated risk of developing it.
135 million adults.
I need to pause on that.
It's massive.
That is a massive portion of the population. That's like entire countries worth of people walking around either managing this condition or standing right on the edge of it. And that scale is exactly why there is a massive demand for reliable, science-backed nutrition guidance. I mean, when that many people go to their doctor and ask, hey, what should I eat to fix my blood sugar? The medical community needs to have answers that are based on rigorous, up-to-date science.
Not just lingering assumptions.
Exactly, not just assumptions. But the problem is, for decades, the advice has essentially been to swap your beef for chicken.
Right. And I think we need to talk about why that advice became so common in the first place. Because, the medical community didn't just pull the beef is bad idea out of thin air. There was a theoretical mechanism behind it, right? It was largely driven by the fear of saturated fats.
Yeah, that is the historical context we really have to keep in mind here. For a long time, the prevailing theory was that the specific type of saturated fats found in red meat could lead to something called lipotoxicity.
Lipotoxicity. Okay, what is that?
Basically, the idea was that these fats would accumulate in places they shouldn't, like the pancreas.
Oh, wow.
Right, and directly interfere with the cells responsible for managing blood sugar. And then on top of that, there were also concerns that the high levels of heme iron in beef could cause oxidative stress.
So it's like a double whammy.
Yeah, potentially further damaging metabolic function.
Okay, so we had a very plausible theory. The saturated fat and the iron might damage the pancreas, so the logical advice was to tell those 135 million people, hey, eat poultry instead, since it's generally lower in saturated fat and heme iron.
Right, it makes sense on paper.
It totally makes sense on paper. But it feels like we are running our diets on outdated software,
That's a good way to put it.
We just keep booting up the chicken is always better operating system without ever stopping to ask if there are new patch notes.
Yeah.
Like, we accepted the theory, but maybe we stopped testing the actual end result in modern controlled environments?
And that tension between an accepted theory and actual clinical data is precisely the question that drove these researchers at Indiana University.
It's so easy to just rely on the old theory.
It is very easy in science to accept an old premise and just build new guidelines on top of it. But sometimes you really have to go back to the foundation and stress test the bricks.
I love that.
They wanted to strip away the assumptions, put beef and poultry head to head, and look purely at the metabolic data.
Because if the problem with past nutrition advice is that it relied on messy observational data like asking people how many burgers they ate last year, then the only way to actually bust this poultry assumption is to completely control the environment.
Exactly. Which brings us to the design of this clinical trial.
Yeah, I was looking at the methodology, and what stood out to me wasn't just how they tested, but who they tested. Like, they didn't recruit 20 healthy college athletes where anything they eat gets instantly burned off.
No, the demographic they chose was highly specific and entirely relevant to the problem.
Okay, who were they?
They recruited 24 adults, so 17 males and 7 females, ranging in age from 18 to 74. But the crucial detail is their baseline health status. Every single one of these participants was overweight or obese and had prediabetes, but they were otherwise generally healthy.
Okay, so they picked the exact demographic that is most vulnerable to metabolic dysfunction.
Exactly.
These are the people whose bodies are already struggling to manage blood sugar. If beef is truly a metabolic villain, this is the group where that villainy would show up the fastest, right? And the
Yes.
most clearly. It's the ultimate stress test for the food.
And to conduct that stress test, the intervention required the participants to eat 2 meals a day containing either cooked beef or cooked poultry.
2 meals a day,
Yeah, and the total amount consumed was about 6 to 7 ounces of meat per day.
which breaks down to what, a standard 3 to 3.5 ounces per entree?
Exactly.
What's interesting about that portion size is how realistic it is. Like, we are not talking about forcing people to eat a 32-ounce tomahawk steak every single day just to see if they get sick.
Yeah, no.
6 or 7 ounces a day is a very standard dietary intake. And the meals themselves were practical, too. I think the text mentioned fajitas, burgers, stew, burritos, stir fry.
Yeah, everyday foods,
They simulated a normal, everyday American diet.
which is vital.
Yeah.
Using realistic meals is vital for a dietary study. If you want to know how food affects people in the real world, you have to serve food that people actually eat, prepared in ways they would actually prepare it.
Makes total sense.
But the real magic of this study's methodology, the reason it is considered a gold standard clinical trial, is its architecture. It was a randomized crossover trial.
Ah, okay. That term crossover gets thrown around a lot in nutrition science. But it makes a massive difference in how much weight we can give to the results, doesn't it?
Oh, absolutely. It's huge.
Because in a standard, like, parallel study, you would just take your 24 people, put 12 of them on the beef diet and 12 on the poultry diet, and compare the two groups at the end.
Right. And the inherent flaw there is that human bodies are incredibly diverse. Even if everyone in the study has prediabetes, Group A might just naturally have slightly better baseline metabolisms.
Or different sleep habits.
Yes, or different stress levels than Group B. All of that biological noise skews the data.
Think of it like testing two different skincare routines.
Okay, I like this.
Right. So if I test routine A on my face and routine B on your face, the results are going to be completely messy.
Yeah, for sure.
Maybe you just naturally have perfect skin, or, my skin is having a bad reaction to the weather that week. But a crossover design is like testing routine A on my face for a month, taking a break so my skin completely resets, and then testing routine B on my face for another month.
Exactly.
I am comparing the results against my own baseline. You become your own control group.
That is a perfect analogy because every single participant followed both diet plans during the study. The researchers could look at how the exact same body reacted to poultry versus how it reacted to beef.
Wow, so no guessing about genetics.
None. The study was structured so that each participant completed a 28-day diet period on one meat, then took a 28-day washout period.
A washout period.
Yeah, where they basically went back to their normal habits to let their metabolism reset. And then they crossed over to do another 28-day diet period on the other meat.
That's brilliant.
It effectively removes the genetic and lifestyle variables that usually cloud nutrition studies.
Okay, so we have 24 adults at high risk for diabetes, eating practical everyday portions of beef or poultry and acting as their own control groups.
Correct.
The methodology is incredibly robust. So let's move from the plate to the pancreas. Let's look at what actually happened inside their bodies during those 28-day phases.
Right. And to understand the results, we have to look at the cellular level, specifically at something called pancreatic beta cells.
Beta cells.
Yes. The text explains that type 2 diabetes usually develops gradually, over years. As a person gains weight or becomes less active, their body often becomes more resistant to insulin.
Okay, let me try to visualize this. If insulin is like the supply chain moving glucose out of the blood and into the cells, insulin resistance is like a massive backlog at the loading dock.
Yes, that's exactly it.
The cells are full, they stop accepting deliveries, and the sugar just piles up in the bloodstream.
Right, it has nowhere to go.
And the pancreatic beta cells are the dispatchers in this scenario, right? They are the ones sensing the sugar and sending out the insulin trucks to deal with it.
That is a brilliant way to visualize it. And what happens in prediabetes is that those beta cell dispatchers start to fail.
Because they're overworked.
Exactly. Because of the backlog at the loading dock, they have to work harder and harder, constantly pumping out more insulin to try and force the blood sugar down.
Jeez.
Yeah. And eventually, they burn out from the overwork and start to lose their function entirely. When those beta cells fail, that is when a person transitions from prediabetes into full-blown type 2 diabetes.
Ah, I see. So the researchers weren't just looking at whether the participants gained or lost a pound or two. They were looking under the hood at those dispatchers.
Precisely. To evaluate how the beef and poultry diets affected this deeply complex system of glucose regulation, the researchers measured pancreatic beta cell function, insulin sensitivity, and various glucoregulatory hormones before and after each dietary phase.
That is incredibly detailed.
It gets better. They also measured cardiometabolic markers, things like their triglyceride levels, their HDL and LDL cholesterol, and systemic inflammation.
They were hunting for the microscopic stress signals that indicate the body is moving closer to disease.
Yes.
And what did those markers show after a month of the beef diet compared to a month of the poultry diet?
After 28 days, the researchers found no statistically significant differences between the beef and poultry diets for any of the measures related to pancreatic beta cell function or insulin sensitivity.
Wait. Really? No differences?
None. The cardiometabolic health markers, the triglycerides, the inflammation, were also virtually indistinguishable between the two phases.
Wow.
The expected damage from the beef simply did not materialize.
Oh, yeah. I want to put a speed bump here just so we aren't generating misleading sound bites for people.
Fair enough.
Finding no difference between the beef and the poultry doesn't mean the beef actively cured their prediabetes, right?
I know, definitely not.
It just means the beef didn't accelerate the metabolic damage any faster than the chicken did.
That distinction is critical. The beef was not a magic bullet that reversed their underlying condition. What the study demonstrated is a null result regarding harm.
A null result.
Right. The daily consumption of unprocessed beef produced results that were fundamentally similar to poultry. Unprocessed beef did not uniquely harm their metabolic markers.
Which directly contradicts that old widespread assumption about lipotoxicity and beta cell damage that we discussed earlier.
Exactly. It contradicts it completely.
It is a massive paradigm shift. I mean, it tells us that the poultry assumption was, at least in this specific context, just an assumption. So what does this all mean? If you are someone actively managing your blood sugar, how do you actually operationalize this data?
Well, we could look to Dr. Kevin C. Mackey, who is an adjunct professor at the Indiana University School of Public Health and the senior author of the article.
Okay, what did he say?
He synthesized the findings by stating that these results build on existing scientific evidence showing that when beef is consumed as part of a healthy dietary pattern, it helps fill essential nutritional gaps.
Those essential nutritional gaps are worth highlighting, I think, because beef is incredibly nutrient dense.
Oh, absolutely.
It is one of the best sources of bioavailable iron, zinc, and crucial B vitamins like B12.
Yes.
But for decades, people dealing with prediabetes have been actively avoiding those nutritional benefits because they were terrified of the metabolic consequences.
Exactly.
And this study is saying the metabolic consequences are basically identical to the chicken they are already eating.
It removes the metabolic fear factor from a very nutrient-rich food source, provided it is eaten within the broader context of a balanced diet.
Right.
It gives people permission to diversify their protein sources without the anxiety that they are sabotaging their blood sugar.
Okay. But as with all deep dives, we cannot just take an exciting headline and run with it. A surprising result naturally invites skepticism, and it is time we examine the fine print of this study.
Always a good idea.
So who paid for this rigorous gold standard trial?
The research receives funding from the National Cattlemen's Beef Association, which is a contractor to the Beef Checkoff program.
Okay, here's where it gets really interesting.
You're going to say that.
Well, yeah, because any listener with a critical eye is going to throw a red flag on that play.
Naturally.
An industry-funded study just happens to find out that the industry's specific product is perfectly fine for you. It sounds like a massive, undeniable conflict of interest. Like, how can we possibly trust a result that is so incredibly convenient for the people writing the check?
This raises an important question about how we evaluate scientific literature in the modern world. The reality of modern science is that large, rigorous clinical trials are incredibly expensive,
Yeah, that's true.
and government grants don't cover everything. So industry funding is a very common mechanism, but it absolutely requires us to look at the methodology with a magnifying glass.
Definitely.
However, we have to look at the specific guardrails the researchers detail in the text to protect the integrity of the data.
Okay, so what exactly does that firewall look like? Because a simple promise of "we didn't tamper with the data" isn't going to satisfy someone who is really skeptical of industry influence.
The publication explicitly outlines the boundaries. The National Cattlemen's Beef Association provided the funding, but they were not involved in collecting the data.
Okay.
They were not involved in analyzing the data. Furthermore, they did not participate in the publication process, aside from being allowed to review a draft of the manuscript before it was submitted.
So they basically just funded the logistics.
Exactly. They wrote the check to fund the logistics of the trial, but the execution, the blood draws, and all the statistical math were handled entirely independently by the university scientists.
That separation of church and state is crucial.
It really is.
We shouldn't blindly trust industry-funded studies, but we also shouldn't blindly dismiss them if the methodology is transparent and sound. And looking back at the crossover design, it acts as a built-in lie detector, doesn't it?
It does.
You are measuring specific cellular hormones like insulin and objective markers like triglycerides. The blood either shows insulin resistance or it doesn't. You can't really fudge beta cell function in a lab report.
That is exactly why the crossover design is considered the gold standard. It minimizes the opportunity for subjective manipulation. The data is simply the data.
Okay, but there's another caveat in the fine print I want to throw at you.
Let's hear it.
The study phases were only 28 days long. 1 month on beef, 1 month on chicken. If we are talking about a chronic disease like type 2 diabetes, which usually develops over years and years of metabolic stress, is a 1 month window really long enough to tell us anything useful? What if the saturated fat takes 45 days or 6 months to start showing that lipotoxicity we talked about?
That is an excellent piece of critical thinking. The time frame of any study dictates the scope of its conclusions.
Right.
And the researchers actually addressed this limitation directly. Dr. Indika Adizain, professor of food science and nutrition at the Illinois Institute of Technology, who commented on the study, noted that while the duration was relatively short, a 1 month time frame is generally considered sufficient.
Sufficient to see what?
To detect measurable metabolic outcomes for these specific risk factors.
Ah, okay. So because they are looking at the microscopic precursors, the insulin sensitivity, the immediate inflammatory markers, the beta cell strain, 1 month, is enough time to see if the biological needle is moving in the wrong direction.
Yes. They aren't waiting to see if someone develops full-blown clinical diabetes. They're looking at the dashboard warning lights.
That makes sense.
And over 28 days of eating beef twice a day, those warning lights did not flash any more brightly than they did with poultry. If beef were the acute metabolic toxin it is sometimes portrayed to be, you would expect to see the beginnings of that strain reflected in the blood work after 4 weeks of daily consumption.
But they didn't.
No, the metabolic needle didn't move toward danger.
Let's pull all of this together for the listener. We started with a massive public health landscape, 135 million adults staring down prediabetes or type 2 diabetes,
Right.
and a deeply entrenched cultural belief that chicken is a metabolic savior and beef is a metabolic villain.
And we arrive at a highly controlled gold standard clinical trial demonstrating that, at the cellular level, the bodies of individuals with prediabetes process unprocessed beef and poultry with remarkably similar metabolic outcomes.
If you or someone you know is actively managing prediabetes, the takeaway today is not to throw out all your health goals and start eating a completely unhinged diet.
Definitely not.
The takeaway is about reducing the daily anxiety of food choices and expanding your options. Realizing that a standard 6-ounce daily portion of beef in your stir fry or your fajita is not the metabolic villain it has been portrayed to be.
Exactly.
It is no more of a villain than the chicken breast you might have been forcing yourself to eat.
If we connect this to the bigger picture, it all goes back to the context Dr. Maki emphasized. It is about consuming these foods as part of a healthy dietary pattern.
The pattern is what matters.
Yes. If that beef is covered in highly sweetened sauces, sandwiched between highly refined carbohydrate buns, and served with a mountain of deep-fried potatoes, your blood sugar and your beta cells are absolutely going to suffer.
Oh, for sure.
But the data suggests it is not the beef itself that is driving that metabolic failure.
Which brings me to a final thought I want to leave you with, because there is one highly specific word the researchers used in their conclusion that changes the entire context of this conversation.
Yeah, this is key.
The word is unprocessed. The study specifically noted that daily consumption of unprocessed beef produced these safe results. The researchers were cooking real, whole cuts of meat.
Right.
They were not serving highly preserved, chemical-laden, ultra-processed meat products like hot dogs or shelf-stable sausages.
That distinction is paramount. Processing completely changes the biological matrix of the food. It introduces preservatives, excess sodium, and altered fats that have entirely different effects on systemic inflammation and metabolic health.
It makes you wonder, if unprocessed beef acts just like poultry in our bodies, perhaps our whole cultural conversation about nutrition has been looking in the wrong direction for the last 30 years.
It's very possible.
We blamed the cow for our failing metabolic health. But maybe we need to stop demonizing the animal itself and start looking much, much closer at the factories and the industrial processing plants that alter, preserve, and reshape our food before it ever reaches our plate.
That's the real issue.
Is it the cow that is making us sick? Or is it what the factory does to the cow after it leaves the farm? Just something for you to ponder the next time you are standing in the grocery store aisle trying to make a healthy choice.
Well said.
Thank you so much for joining us on this deep dive. Keep asking questions, keep challenging those old assumptions, and we will catch you next time.